Okay, so our last discriminant video, if you take a quick glance at the equations, you can see these aren't quite as straightforward as the last two videos. So, of course, it gets a little more complicated. We're in Algebra 2 now. We can handle some complexity in our work. All right, so example 5, first thing is you want everything on one side, 0 on the other side. So I'm going to go ahead and subtract 2 from both sides. Gives me d squared plus 7/3 d minus 2 equals 0. All right, so it's in standard form. We know a is equal to 1. Here's the part we're not going to like so much about this. Our b is equal to 7/3, and our c is equal to -2. That's okay. We'll just still find the discriminant like we normally do. So discriminant is b squared, so 7/3 squared, minus 4 times 1 times c, which is a -2. All right, well, what is 7/3 squared? That's just a 7/3 times 7/3, so that's 49/9. And then I check out for negatives. I have 1, 2 negatives. If you multiply 2 negatives, it becomes, positive. So that just tells me I can say plus. And then 4 times 1 times 2 is 8. So 49/9 plus 8. Feel free to use your calculator for that. I mean, the focus here is understanding what the discriminant means. When you add those together, you do get 121 over 9. So there's our discriminant. Now what we need to figure out is your discriminant positive, negative, or equal to 0? This discriminant is greater than 0. So what does that tell us about our roots? Our roots are real because our discriminant is greater than 0. They are not equal to each other. And 121 over 9, is that a perfect square? Well, 121 is a perfect square and 9 is a perfect square. So you could square root both of those and get 11 over 9. So we're going to say yes and say that this is rational. So we've got our discriminant and we've got our determine the nature of the discriminant. That's the way the directions sound on these problems. All right, let's try another one. Is this one in standard form ready for us to identify the a, b, and c? No, it is not. We're going to do some multiplying out. We're going to take care of the squared first. So x minus 1 squared means x minus 1 times x minus 1. You guys remember how to FOIL? X squared minus x plus 1. So it's x squared minus 2x plus 1. But then see how there's that 3 out in front of whatever x minus 1 squared is? Well, here's x minus 1 squared, and let's put the 3 out front. And then it still equals 3 on the other side. So now we can go ahead and distribute that 3 to give us 3x squared minus 6x plus 3 equals 3. Now for the discriminant, before we identify a, b, and c, we want to get everything on the same side. So I'm going to go ahead and subtract this 3 from both sides, leaving us with 3x squared minus 6x. Those cancel, so it just equals 0. So now that we have standard form, go ahead and identify your a, b, and c. Well, a is in front of x squared, that's 3. B is in front of the x, so it's -6. And then do you see how we don't have that c value? It's very possible that you won't have that. That just means that it's a 0. So we find our discriminant, b squared minus 4ac. So here's our -6 squared minus 4 times a times c. So -6 squared is a positive 36. I look for my negatives. I have 1 negative, nothing else, so I know that's going to stay minus. And 4 times 3 times 0 is 0. So our discriminant is equal to 36. All right, so what do we know when a discriminant is equal to 36? our discriminant is greater than 0. It's a positive number. So that means that our roots are real numbers. They also are not equal to each other. There will be two different numbers. And then look to see, is 36 a perfect square number? And if it is, that means that the roots are rational.